In the next series of videos, we are going to discuss about natural language processing basics. So we will try to cover the concepts behind the natural language processing, and then we will try to explore the applications that are based on natural language processing. So before proceeding to those videos, first I will try to briefly describe about the natural language processing. So in 1970s, what we have done is we have tried to use the binary language to communicate with the machines. For example, we have used zeros and ones to communicate with the computer. This is called binary language. And then in 1980s, people have invented assembly language. For example, if you want to add two numbers, then you can just give this instruction. This instruction will be converted to binary language, and that binary language will be understood by the machine. So this is one of the improvements from 1970s to 1980s. And then in 1990s, people have invented the high level languages like C++, Java, and etc. So here in each decade, people are trying to remove the hurdles and are trying to give the flexibility to develop the many applications. So in 2000, people have started to explore many things, and they have come up with the natural language processing. So what is natural language processing? Natural language processing is a technology which helps to interact between humans and machines with natural language. So for example, if you have used Siri, Apple Siri, or Google Hello, like that, you would have noticed that if you can communicate with the machines by your natural language. So that's a very powerful application, that's a powerful tool to communicate with the machines. So for example, if I want to book any tickets or book any movie ticket or flight ticket, I can just ask the Siri to book tickets on particular date, on particular with a particular members, like that. So here that application is trying to reduce the manual effort and trying to help us in many ways. So that's the power of natural language processing. And then there is a formal definition. Natural language processing is a field that covers computer understanding and manipulation of human language, and it drives the possibilities for new scattering. So this is the formal definition by Antony. So here what it states is natural language processing is a field which is trying to cover the barrier, which is trying to overcome the barrier between the humans and machine. So and then finally comes the applications. So this video is about only NLP basics. In the upcoming videos, we will try to cover the concepts of NLP. So please try to stay tuned with this series of videos. So let's come to the applications. So automatic summarization. So for example, you would have noticed in Google, so if you want to read any blog which has thousands of lines, so what Google does is it will try to convert these thousands of lines to 10 to 20 lines of summary. So we can just read that 10 to 20 lines. If we like that 10 to 20 lines, then we will try to read the complete blog. So that's the power of automatic summarization. And then comes the translation. So I personally love the Google Translator, because if I want to translate from one language to another language, instead of using some language known person, I used to use a Google Translator, which helps me in many ways, and it also saves me tons of time. So you can translate from English to Chinese, Chinese to Tamil, Tamil to Telugu, etc, etc, etc. And then comes the named entity recognition. Named entity recognition means if we want to detect any entities in a sentence or paragraph. For example, India is my country. Here India is a named entity. So India is a country, and then there are n number of entities like person, time, date, and etc, etc. Suppose if you want to detect those entities, then you can use this application. And then comes the relationship extraction. Relationship extraction means if you want to extract a relationship between two entities, then it would be very useful. So these are some common applications that are derived using natural language processing. We will try to dive in deep in those applications in the upcoming video. So please stay tuned to this series. Now we are going to discuss about the tokenization and its methods and its usages and its various models available in tokenization. So first, what do you mean by tokenization? Tokenization means it will segment then input character sequence into tokens. So for example, consider this is a character of sequence. sequence of characters. John is a person dot. So John space is space a space person dot are the sequence of characters. Here we need to split these characters into tokens. So the first approach would be splitting using whitespace. So John is the first word, is the second word, A is the third word, person dot is the fourth word. Here we can't use that person dot for the further processing easily. So for that we need the better tokenization approach. So better tokenization means you need to split this person dot into person whitespace dot, then only we can use this in output for further processing. That would be handled by using NLP tokenization methods. So we will try to cover those things in the later part of this video. And then second point is tokens can be words, numbers, punctuations and etc. So it can be anything. So tokenization tokens are not only restricted to words, it can be numbers, it can be punctuations, it can be anything. So this is the example of tokenization using NLP. Here you could see the difference between the actual normal tokenizer and then NLP based tokenization. So here John Peter comma space. So here this comma needs to be separated. So that's the final output. Here comma is separated using whitespace. Similarly for world. Whereas in case of NOV November dot, the NOE dot is not separated using whitespace. The reason behind it is it's an abbreviation. NOV dot is the abbreviation for November. So that's why NOV dot is not separated using whitespace. And then 29 dot. So 29 dot got separated using whitespace, 29 space whitespace. So this is called tokenization using NLP example. So you could see the actual difference between the normal tokenization and then NLP based tokenization. Here the NLP based tokenization knows where to split and where not to split. So in the case of NOV dot, it is not splitting because it is the abbreviation for November, whereas in case of 29 dot, it's not the abbreviation for anything, it needs to be splitted, it needs to be separated, that's why it got separated. So there are three types of tokenizers: whitespace tokenizer, and then simple tokenizer, and then learnable tokenizer. Whitespace tokenizer is, it will try to separate the tokens using whitespace. For example, this is the sample sentence: John space is space a space person dot. Here if you use the whitespace tokenizer, the final output would be first token John, second token is, third token a, fourth token person dot. If suppose the output, the final output, which means the four tokens are not very helpful for the further processing because person dot cannot be consumed directly. We need the final output as John first token is, second token a, third token, person fourth token, and then dot is the fifth token. That's our expected output, but when we use a whitespace tokenizer, that won't be the final output. And then simple tokenizer tries to use simple rules to tokenize this sentence into granular tokens. And then learnable tokenizer is the NLP based tokenizer. Here it uses the maximum entropy algorithm to tokenize the sentences into granular tokens based on probability model. This example is based on NLP based tokenization, which is learnable tokenizer. We will try to cover an example about the learnable tokenizer algorithm in the further videos. So thanks for watching. Now we are going to discuss about document categorizer in a brief manner. So first, what is a document categorizer? So document categorizer is a technology or concept which is used to classify text into predefined categories. So there can be n number of categories. It can be 10 categories, 20 categories, it can be million categories. So for example, if you consider Google, the news would be categorized into various categories like weather category, sports category, and then politics category, like that. So in each category the news should be very specific to those categories. That's the important use case of document categorizer. So another definition is it's a supervised learning. Supervised learning means we need to manually teach the machine each and everything about the sentences or paragraphs. So for that, what we need to do is we need to label the data. Label the data means we need to manually train the machine with the labels. So this is the document name, and then this is the sample sentence. So the sentences which are similar to these things will be categorized as GM decrease. Another sentence is GM increase is the document name, and then this is the labeled, this is the sample sentence. So you need to collect millions of data, millions of training data. So basically there would be 3 stages in document categories: step 1, step 2, step 3. These can be 3 steps or it can be 3 stages. The first stage would be collecting labeled data. Labeled data means you need to manually collect data similar to this. So you need to manually collect data for GM increase, similarly for GM increase. So this is the first stage. Second step is using that label data. What you need to do is you need to give the label data to some algorithm. That algorithm would be document categorization algorithm that would return the doc cat model, which means document categorization model. So this is the second stage, which can be said as training stage. We will try to explore more about the training stage in the upcoming videos. For now, just consider it as a black box. And then stage 3. So here, using the doc-cat model, which means a document categorization model, what we will try to do is we will try to give some random sentence or some sentence which has been trained in this, which has been present in this label data. For example, this is Rakesh. So this is some sample sentence. This document categorization model, what it do is it will try to categorize this is Rakesh into either GM decrease or GM increase based on various probabilities. We will try to explore more about this doc-cat model algorithm in the upcoming videos. Thanks for now. Now we are going to discuss about named entity recognition. So this is the important concept in natural language processing. So if you want to develop any natural language processing application, then without this concept you can't develop any simple application. So that's the power of this named entity recognition. So it's an important, it's a compulsory, it's a mandatory video for those people who are trying to develop any natural language application. So the basic definition of named entity recognition is it detects named entities like person, organization, place, date, and etc. So we can relate that with an example. So for example, John is a boy is an example, is a sentence. In this, the named entities are John is a person. So similarly, we can write another example called John lives in India. Here, John is a person and then India is a location. So here we have 2 named entities in this simple sentence. So that can be n number of named entities like location, organization, person, facility, daemon, etc, etc, etc. So you could have a question, why should we detect the named entities for natural language processing? So for natural language processing, first step would be tokenization. You need to tokenize the sentence into further granular tokens, and then you need to you need to determine the entity type for those tokens. For example, John, which is a person, India, which is a location, and then only we can understand the actual context of this sentence. So that's the reason why named entity recognition is the important part in natural language processing. It is a supervised learning. Supervised learning means we need to teach the machine about the then only machine tries to understand, then only machine tries to predict based on our teachings. So it predicts the entities based on model which was trained using labeled data. What do you mean by labeled data? That's your point, that's your question. I will try to answer that using this slide. Label data means we need to manually tag the data with named entities like John is a person, India is a location, like that. For example, suppose if you are studying, if we in LKG, UKG, which means in the first grade, second grade, our teachers would have imposed many things to us. So they will teach like TOG is a dog, KAT is a cat, like that. Similarly, we need to teach our machine that John is a person, India is a location, like that. So for that, this is some standard way of teaching the mission using some label data. This is a sample label data. Here what we are trying to do is we are trying to define the value inside this start and end tag, and we are trying to define the entity type, named entity type, which means person. So anything which is defined inside this end and inside this start would be treated as person. Similarly for location, so anything between the start and end would be treated as location. Here India is treated as location, here John is treated as person. So this is a sample label data. We need to manually collect 10,000 to millions of sample labeled data. So you could do it in either ways, by manually tagging the data, the first way. If suppose if you don't have that much time, you can buy the labeled you can buy the tagged data from the third party sources. So first part in named entity recognition is collecting the tagged data. So there won't be any limit for this tag data. If you collect 1 million, that's good. If you collect 10 million, that's too good. So that is no limit. You can collect n number of sentences of tag data. That would be very helpful. So it depends complete on how much variety you have collected the data. And the second step would be training stage. So we need to manually train the machine by teaching that John is a person, India is a person, India is a location, like that. So we have collected the tag data. So let's consider we have collected 10,000 tag data, 10,000 tagged sentences. Using these sentences, what we will try to do is we will try to give the sentences to this algorithm. This algorithm is called maximum entropy named entity recognition algorithm. It can be any algorithm like perceptron algorithm, maximum entropy. It depends. There are a number of algorithms which will try to detect the named entities. So we will try to give this 10,000 tagged sentences to this algorithm. It will try to give the model to us. NER model. So this is the final output of the training stage. So we will try to consider this is a black box for now, because we are not trying to dive into detail regarding the working procedure of this algorithm, like that. So we will get some model. So and this third and final step would be test. So using this NER model, which means using this NER model, we can give any sentences of any type. For example, if I give Rakesh lives in Chennai, this sentence is very new and this sentence is not present in this training data. So model doesn't have any idea about this sentence, but it will try to predict this Rakesh is a person and then Chennai is a location because of this algorithm. We will try to explore this algorithm in a better manner in the upcoming videos. For now, just consider there are 3 steps in a named entity recognition. First one is collecting the tagged data, and then second step would be training stage, where we need to manually train the machine with the algorithm that would eventually give the NER model. Using that NER model, we will try to test the new set of sentences. Thanks for watching.